going to go ahead and take a look at compound interest. So we have a special formula, A equals P times the quantity of 1 plus R over N raised to the NT power, where A is the total amount, P is the principal or starting amount, R is that interest rate as a decimal, the N is the number of compounds per year, and T is the number of years. Now, when I say number of compounds, I'm talking about how many times this interest upon interest has been recalculated. Notice that this NT is up in the exponent. Because of this, the compound interest formula climbs faster than simple interest. Some common uses are in savings accounts and money market accounts, CDs or certificates of deposit, as well as some credit card accounts. Let's go ahead and take a look at some examples. So in example 4, I've been told that we're going to be using a credit card to pay for $21,000 worth of medical treatments. You plan to pay it back on time, but unfortunately something went wrong. Now, your interest rate is 13.6% and it's compounded quarterly. And it ends up going to take you 4 years to pay it all back. So, how much did you end up paying it all? Well, let's go ahead and break down what we know. So, we've been told the principal. So P equals 21,000. We also know the interest rate. R equals 0.136. We know the number of compounds, 4. And that 4 is because it was quarterly, so it's happening 4 times a year. And we made these payments for 4 years. All right. Let's go ahead and plug this all into our formula. So we've been given that A equals, and again I'm going to be using P, 1 plus R over N raised to the NT. Okay, so I have 21,000 times the quantity of 1 plus 0.136 over 4 raised to the 4 power times another 4 up top. So altogether, 21,000, 1 plus 0.136 over 4 raised to the 4 times 4 is a 4 there. All right, let's go ahead and type this into the calculator. So we have 21,000 times 1 plus, put in our fraction, 0.136 over 4, and again, this fraction here is R over N, raised to the NT power. That was the 4 times 4, which is a 16 up top. There we go. Alrighty, so after 4 years, you ended up paying $35,854.85. Okay, so let's come back to here. Again, final amount was in dollars, $35,854.85. So again, you took out a $21,000 loan. After 4 years, you actually ended up paying $35,854. Let's take a look at another example. Belana invests $4,848 in a savings account with a fixed annual interest rate of 5% compounded 2 times per year. Now, just so you know, a 5% interest rate in a savings account is a pretty good deal. So, let's say you have this situation and you want to figure out what's your balance after 6 years. Well, let's go ahead and break down what we've got. So, we've been given the principal. So, 4848. We know the interest rate. That 5% becomes 0.05. 2 times per year, so that N equals 2. And another name for 2 times per year is semi-annually. And our time period is 6 years. Okay? And we're going to be plugging all of this in to A equals P 1 plus R over N raised to the NT. Okay, so we have 4848 times 1 plus 0.05 over 2 raised to the 2 times 6. So raised to the 12th. Okay, we're going to go ahead and plug this into the calculator. So 48, parentheses, 1 plus, put in our fraction, 0.05 over 2, all raised to the 2 times 6, which is 12. And again, it's 12 because n times t was the 2 times 6. So overall, it looks like our total amount is going to be $6,520.02. Okay, so you started by investing $4,848, and based on this interest rate, after 6 years, you have a total of $6,500. So $6,520.02. So back up to top here. Again, this is called compound interest. P times quantity of 1 plus R over N raised to the NT power. T is the number of years you're counting, and N is the number of compounds per year. This could be daily, weekly, monthly, semi-annually. It could be anything, including quarterly, or perhaps we'll give you some other time frame, like every 3 weeks. In which case, you take the full amount of time period in the year and figure out how many chunks this occurs inside that single year.